You don't have time to investigate and resolve every security alert, so let Microsoft Defender ATP do it for you. This video demonstrates how to set up and use automated investigation and response. Alerts are the starting points for automated investigations. Each alert includes a rich context of all the involved entities, like files, scripts, and processes, as well as details about the attack's technique. Once Microsoft Defender ATP raises an alert, an automated investigation and remediation begins. The investigation runs multiple AI-based playbooks to better analyze and extend the scope to ensure no threat was left unhandled. For example, Microsoft Defender ATP looks at its rich set of historical data to see if a related threat was seen on other machines, and if so, it'll add those to the same investigation. How Microsoft Defender ATP remediates any threats it finds depends on how you configure automation levels for the machine. That's next. You define automation levels in machine groups, and in this machine group, you see the automation levels available. Not protected disables automated investigations on this machine group. We don't recommend this automation level. As the name implies, semi require approval for any remediation, requires approvals for all remediations. Nonetheless, investigations still happen automatically. Semi require approval for non-temp folders, enables automatic remediation for any file in a temp folder or a user's download folder. And semi require approval for core folders, enables automatic remediation for any file that's not in a system directory, like the Windows or Program Files folders. Last, full remediate threats automatically allows Microsoft Defender ATP to perform all remediation actions automatically without approval. The question remains, what do automated investigations look like in Microsoft Defender ATP? Coming up. The Automated Investigations list shows investigations for the past week, although you can change that time frame. You can customize the list's columns, export the list to an Excel spreadsheet, change the number of items it shows per page, and of course, filter the list by status, triggering alert, detection source, and machine names to zero in on the investigations you care about. The triggering alert column shows the alert that triggered the investigation, and the status column explains where an investigation is in its life cycle, from running to remediated. Of course, you can drill into any of the investigations to learn a lot more about them. That's coming up next. An investigation details page provides a tremendous amount of information about what started the investigation, how it progressed, and what Microsoft Defender ATP discovered once it finished. The top of the details page shows when the investigation started and when it ended. The chart is an interesting bit that compares how much time elapsed versus how much time was spent waiting for the machine or approvals. The left sidebar provides basic information, like its status, severity, and detection source. However, most of the meat is in the investigation graph. It's a picture of the automated investigation that summarizes the alerts, entities, machines, and threats associated with it, plus the elapsed time and status. Click any icon to open the relevant section where you can see more information about it, or you can click any section heading instead. If you want the Cliff Notes version of the investigation, then have a look at the Key Findings section. It lists the entities that Microsoft Defender ATP flagged as being suspicious, malicious, and those it remediated. Depending on the automation level setting, you might need to approve pending actions to remediate malicious entities. Review and approve those on the Pending Actions page. Each investigation you see in the list requires approval before it can continue or be completed. Select a pending action, review its details, and then select either Approve or Decline. Approve means to approve the remediation action, and decline means that you don't want to take action on that entity. And rather than doing them one at a time, it might be easier to select a number of them and approve or decline them in bulk, like this. Microsoft Defender ATP gathers a huge store of information that can help you detect, investigate, and respond to advanced threats. In this video, I'll demonstrate how to use advanced hunting to query and use all that data. Advanced hunting is a powerful query language that's flexible and rather simple to use, especially considering it uses IntelliSense to autocomplete operators as you build queries to mine the telemetry that Microsoft Defender ATP stores in tables. For example, you can query process creation, network communication, and many other event types. Detailed schemas are available for all of them. Some results, like machine and file names, link directly to detail pages in the portal, helping you pivot easily between the advanced hunting and portal investigation experiences. Big time saver. And last, the welcome page provides basic and advanced examples to get you started with the tables and query language. In Microsoft Defender Security Center, on the Advanced Hunting page, the sidebar shows the schema you use to build queries. There's one list for each table, like machines or alerts, and each list contains the table's columns. For example, columns in the File Creation Events table include the file name, folder path, hash, and many other data points. Likewise, the Machine Info table contains columns for the operating system, IP address, and so on. I'll use these tables later to build an advanced query. You won't find a description of these columns in the schema, but take a look at the Advanced Hunting column reference. It provides detailed information about each, including its data type and description. Before showing you how to build advanced queries using this schema, we recommend getting to know the basic examples. That's next. The Get Started section contains examples that show how to query Microsoft Defender ATP telemetry. There are two sets, Basic and Advanced. I'll start with the basics. Under Project, select Run Query to run the example. This is a simple query language that has elements of PowerShell, like the pipe character. It uses the where operator to select rows from the File Creation Events table created in the last hour. The limit operator restricts the results to 1000, and the project operator selects specific columns, like the file name and event time. Below the query are the results. To view details about an entity in them, like machine details, select the hyperlink to open them in a new tab. With this basic example under your belt, building a custom query that extends it is a great learning opportunity. Next. Ultimately, I want to build a query similar to the basic example, but I want information about machines that are defined as high-value assets, along with a number of failed logins. So, I'll start with the Machine Info table and filter the results to show machines that are tagged as a high-value asset. To select the columns I want to show, add the project operator, followed by a comma-separated list of columns. Last, use a join operator to merge the Machine Info and the Logon Events tables to include logon events in the query. This way, you can hunt through a smaller number of failed logon attempts for the most valuable assets in the org. That's it. Run the query and you see the results. Results are clickable and bring you right to this specific event on the machine timeline. Next, I'll show the advanced filter capabilities you can use to refine the results further. After running a query, you can filter its output. Each column in the results has a section in the filter, and within each, you see a list of unique values for that column sorted by prevalence. Refine the query by clicking the plus or minus signs next to a value to include or exclude it. As a result, the filter adds a where operator to the query statement. Run the query again to update the results. Another nice ability is custom detection, based on my own queries. I'll describe how to do that in the next segment. Custom detection rules are queries that run as a scheduled task. When the query has results, it surfaces an alert, just like any other alert. They do require the event time, machine ID, and report ID columns in the query. I'm missing the event time and report ID columns, so I'll slip those in there. Once the query is ready, creating the detection rule is simple. It needs a name, metadata like the severity and category, and a description. Select Create to save the rule. After the query runs, here's what the custom alert looks like in the Security Operations dashboard and the Incidents dashboard.